Cisco Certified Network Associate Day 39. Welcome back everyone, I'm Imran Rafai, your trainer for this entire series. Today we're going to discuss switch stacking versus chassis aggregation, and this is part of ICND2 topic. So without wasting much time, let's get straight into today's class. And before we go ahead, click on that subscribe button and then click on that bell icon to be notified whenever we update a new video. And also please click on that like button under this video, which would make us very happy. We have our company social media contacts on the left, my personal social media contacts on the right, and my email address is given here. So anybody who wants to contact me, please feel free to contact me on imran.rafai@nwking.org. Like I said, today we're going to look at the benefits of switch stacking versus chassis aggregation. This is part 1.6 of ICND2 exam topics. So in a typical world, when you're looking at designing a network, we would let's say you are designing a new network, and you come up with a design layout, and then you realize that each floor you need about 100 computers. So that means all the access switches. So let's say in these are access switches and these are distribution switches. If you know the Cisco 3-layer models, a core, distribution, and access layer devices. So on each floor we need 100 devices. Now you need to make a decision between two things. How are you going to achieve this? Because each switch on an access layer switch, you would have about 24 ports. So if you want 100 ports, right, you need to have 5 24 port switches, right? So you need to decide whether you need to go that way, where you have more numbers of small switches, or you have one large switch where you have maybe a switch with 100 ports, right? So it's definitely not part of your ICND1 or ICND2 to discuss such large switches, but you can get a switch with 100 ports. That's possible. So we need to make that decision whether we need to go with a lot of small switches or one large switch, right? Both of them have their own advantages and disadvantages. The advantages of having one switch with 100 ports is that you need to have one, you just have to manage only one switch. You don't have to manage 10 different switches or 5 different switches, right? But at the same point, the disadvantage of having that one switch is there's only one single point of contact, right? So that single point of contact is, if anything fails on that switch, the whole network goes down. But on the other hand, if you have 5 switches with 24 ports, if one of the switches fail, right, there's a chance of one switch failing, but there's very little chance of all 5 switches failing. But let's say one switch fails, the 4 switches are still working, so that means the remaining ports are still working, so your entire network is not down. But the disadvantage, like I said, is you have to have to manage 5 different switches, right? So you have disadvantage and advantage on either case. That's something that you need to make a decision. So typically what you would do is, when you have, let's say in our example here, so you have A1, A2, A3 and A4 are 4 access layer switches, and these 4 access layer switches are connected to 2 distribution layer layer 3 switches, right? Now each of these access layer switches have to be connected to both the distribution layer switches. So if you know the Cisco 3-layer architecture, we spoke about that in one of our old videos. It tells that you have the low switches or the low grade or low powered switches on access layers, then you have a little higher capacity switches in distribution, and then you have the really powerful switches sitting on your core, right? So here in this case we're only looking at access layer and distribution layer. So each of these access layer switches are connected to both these distribution layer switches. So if you only consider A1 has a wire connected to D2 and D1. So these 3, right, between these 3, one of the ports, because of STP, one of the port will get blocked. STP will block one of the ports. Similarly, A2 also, one of the ports will get blocked, STP. Again, A3, one of the port will get blocked because of STP, and A4, one of the ports will get blocked due to STP. So technically you're not using the entire bandwidth of switches. So you have 2 links, one of the link is always down, right? So that's one of the problems. So typically when you have 4 switches, and let's assume this is on the same floor, so typically they would be sitting on one rack like this. So you have switch 1, switch 2, switch 3, switch 4, right? Each of these switches are these are all switches, so you have 4, 5, 6 and 7 switch, right? So you have 7 switches. So like this, when you have access layers, you normally have switches sitting on a rack. Now the problem is, like I said, because there's so many 24, these are all 24 port switches, so 24 into what, here you have 7 of them, so or sorry, 8 of them, right? 1 2 3 4 5 6 7 8, right? So that is 8 into 24 ports, that's 192 ports. So you have 192 ports in this case. But the problem is, you have to have first you need to have a management IP for each of these devices, right? So each of these devices will have a management IP. An SPI is created, but each of these devices will have multiple VLANs. So you need to have, if you want to manage according to VLAN, each of those VLANs will have to have a management IP, right? So these are all the administrative headaches that you need to have. There is a way you can use something called switch stacking. Now what switch stacking does is it creates these let's say these 8 switches. They try to combine them and make one logical switch. So you have 8 physical switches, but they would act like one logical switch. And one of these switches would be a master, right? Let's assume this is a master. And administrator, as an administrator, you only connect to this switch. You make changes, whatever changes that is applied to all these switches, and all these switches will start acting like one device. That's what it is, what switch stacking is. So switch stacking is a way where you of course, switch stacking, Cisco has many stacking technologies, but the one that we're going to discuss is called a flex stack. So this is a flex stack module. At the back of your switch, there is a port where you can insert these modules. So you install this module, and these modules have 2 links. So what you do is you connect multiple devices. So in this case you have 2 devices. So let's say even if you have 3 and 4. So what you do is you connect these devices in series. So you have this to switch 2, switch 2 to switch 3, switch 3 to switch 4, and switch 4 you put a loop back to switch 1. So this goes in a ring formation. So technically all the devices are connected to the loop, so it becomes a ring, right? Now once you do this, one of the device is becomes a master, right? And then all the others are going to be slaves. So these are all slaves, and as an administrator you contact the master and you make changes to the master, and all the devices are going to work, right? So for all practical purpose, after this this switch, right, the switch A1, A2, A3 and A4 will start acting like one switch. So if let's say there is a traffic that's coming on A2, and let's assume A1 is the master. So if there is a traffic coming on A2 and it has to go through a physical link in A3, these 3 devices will actually be physical devices. A1, A2 and A3 will be working because the master is the one that controls all the devices. So if the master is down, the entire logical switch is down, right? But if one of the switch, let's say switch A3 physically is down, A2 and A4 and A1, all these 3 switches will still work as a logical switch, right? So that's what it is. So once that happens, this switch now starts acting like one switch, right? So in earlier case we had 6 switches, and you had to manage 6 different switches and 6 different STP processes, 6 different configurations to manage. So all that were really a headache that you had to do. So this is 4. You think about what would happen if you have, let's say, 100 switches to manage. To get over that, we do what we discussed, the switch stacking. So once one switch is stacked, they act like one logical access layer switch, and with a little bit of configuration of what we learned in our last video, we can start. Now if you remember, each switch has one connection to D1, so there are 4 switches and there are 4 connections to D1. So you can combine those D1s and make that into a ether channel. All the connections going to D2 can become an ether channel, and D1 to D2 already there is an ether channel, right? So now these are all in ether channel, and technically if you see, it is as if there are only 3 devices and you would only have one ether channel, right, which will get blocked and this will, the STP will block this one channel, and still you have made use of these devices. So what happens in this case is switch stacking gives you benefit where you only manage one switch, and that switch manages the entire logical switch. So as an administrator, your overhead has reduced. So there is another technology called chassis aggregation. Now the difference between switch stacking and chassis aggregation is, one, for switch stacking you need to have a special module like we saw here. You have to get a module like this. This is a Cisco Flex Stack module. There is Flex Stack Plus, and there are many other modules which is not part of your ICND 1 or ICND 2 or your CCNA. So don't worry about the technical details about those stacking solutions, but just know that for switch stacking you need to have an external module that needs to be installed on your switch to get that solution. But the other technology is chassis aggregation. Now for chassis aggregation, you typically would be doing chassis aggregation in a big switch. Now this is a Cisco 6500 switch. Now these switches are huge switches, and each of these switches, let's say these are called the line cards. You have 1 2 3 4 line cards of 24 ports, so that's almost 96 ports here. You can add more line cards here if you want, right? So then you can add more Ethernet ports. Now these are called the supervisor card, right? Supervisor cards are the brain for this whole switch. So this is where all the brain happens. So you can see that these switches, these high-end switches already have redundancy. So you have two supervisors, so both of them cannot fail at the same time. One of them will, even if one fails, the other can take over and continue the operation of the switch. So these are really expensive switches, are normally used in distribution layer or the core layer of your network. These also have two power source, right? So you have, this is the power input, this is another power input. You can connect this to one line, maybe from a different substation, right? And you can connect this to another line from a different substation. So basically both of them, let's say power fails in this substation, you still have a backup coming from another substation which will still make sure the switch is still running. So these are really high-end switches. Now again, going back to our old diagram, so you see D1 and D2, they are already in ether channel. Normally when you do ether channel, you know that you're connecting to the Ethernet ports, right? So you're connecting Ethernet ports and you're doing ether channels. That's the thing with chassis aggregation, you really don't need any more extra modules. You can make use of your Ethernet ports and create chassis aggregation. So basically you would connect from line card 1 to line card 1, and then another line card 2 to a line card 2, and then you can take those things, you can combine them together to form a logical distribution layer switch. Again, what happens is, you know that A1 had a line to D1 and D2, so technically A1 had two interfaces, so you could put those, you can do something called as a multi-chassis ether channel program. So you can make use of that technology and create ether channel. So A2 also has an ether channel, A3 has an ether channel, A4 has an ether channel, and you would see that these are now working point to point, right? There is no loop creation here, these are point to point, and that's making use of all the available links without having any problem. So chassis aggregation is what you do, and typically chassis aggregation versus switch stacking. Chassis aggregation normally is done with higher end switches compared to an access layer switch, which is not a very powerful device. Now if you do switch stacking as well, so if you do chassis aggregation for your distribution layer, and if you do switch stacking for your access layer switches, you do a little bit of configuration. You can actually create an 8-channel ether channel, right? So you have an 8-port 8-link ether channel, right? It would technically be like a single line. So you have a distribution switch and you have an access switch, and there's one line connecting between the two. It is just that now, and STP obviously will work, and both of them would be in forwarding state. They'll be forwarding and this will be forwarding. Both of them are happy, and our network is actually being used with very high, it's an 8-link ether channel, so that's a very high capacity bandwidth there. So this is a very short video. explaining the differences or the benefits and disadvantages of chassis aggregation and switch stacking. Thank you so much. If you have any questions regarding this video, please feel free to contact me, write into us, and we would be able to help you. If you have you could also comment on this video right below, and we will try to reach back to you and help you. Thank you so much. We'll see you very soon. Bye bye.